All right. Number one, can I identify the degree of function just by looking at its equation? We should be able to. And more importantly, can I create and model linear functions? All right. These are the big things that we're going to go over today. So, identifying the degree of a polynomial. First off, there's the zero function. And remember, f of x is the same thing as saying y equals 0, right? So if you have y equals 0, that's a horizontal line. It is a function. It does have points on it. But as far as trying to identify the degree of the zero function, that's undefined degree. There is no degree to a zero function. It's undefined. All right? Undefined. Now, as far as a constant function goes, again, it's the same thing as saying y. And let's pick a constant like the number 3. Okay? Now, it says f of x equals a, and a is some constant here, but a cannot be 0. If a was 0, it would be the zero function. So again, a constant, y equals 3, that again is a horizontal line. But that does have a degree. That is not undefined. That actually has a degree of 0. Right? We'll show you. Now, linear function. Okay? Linear function. That has a degree of any guesses? 1. There's a degree of 1. Yeah, we're climbing up the ladder here. It's a degree of 1. Lastly, for a quadratic, when you got something x squared plus something x plus c, what do you think that degree is? 2. You're going to climb the ladder. So just by looking at these, what do you think, where do you think you can identify the degree to each polynomial? The exponent. The exponent of the largest term. This exponent is 2, so there's a degree 2. This exponent here is a 1 technically. It's a degree 1. This right here, for my constant function, technically has 0 for the exponent. There are no x's, right? That's why that's degree 0. And here, anytime we multiply something by 0, it wipes it away. So there technically are no exponents for any variables because you multiply times 0. Okay? The variable for a constant will be multiplied by 3. So it'll be 3 times x to the 0. X to the 0 is 1. Okay? But if I multiply anything to the 0 power, which is 1 times 0, it gets wiped out. That's why your degree is undefined. All right, so let's determine which are polynomial functions. And for those that are, let's state the degree and lead coefficient. Okay? So if we can't find the degree, then we're just going to say that they're not polynomials. All right? So example 1 here, what is the degree and lead coefficient? The degree is 2 here. This one is a degree of 2. Now, what's the lead coefficient? I'll say LC. Well, it would just be 6. Coefficient is a number in front, so lead coefficient is 6. All right? What about example 2? Well, let's see here. The degree is 1, right? And the lead coefficient is 6. It's whatever the coefficient is of the term where you take a degree from. In other words, if I were to write this in standard form, I would write my 6x first, and my positive 11 next. Lead coefficient, degree. All right? Example 3. Now, be careful. Well, yeah, be careful. If I take the square root of both of those, isn't it 3x squared plus 4x? If I take the square root, but don't forget, that does not equal that. I cannot just simplify. If there's pluses and minuses under a radical, I can't just take the square root of each one individually. I would have to try and factor it if I could, the square root. And I can't do that here, can I? I can't do that here. So, guess what? No degree. There's no degree here because I can't simplify that under the radical. Or maybe I can pull out an x squared. Alright? And what about this last one? This last one. There's only two options. It's either -2, it's my degree, or there's no degree. What do you think it is?
No degree.
I would say there's no degree. Your degree has to be 0 or higher. Okay? So this is no degree. Okay? No degree. It has to be 0 or higher. So if we have negative exponents, or if we have some sort of radical that we can't get rid of it by factoring and simplifying, then we can't have a degree there. So, and there's one more thing I want to point out. Let's go to the next slide. Linear functions. What's the equation of a line?
Y.
That's what we know it as. Sometimes, because this is pre-calc, they'll rewrite it. They'll say f of x is the same as y equals a times x plus b, where a is your slope. It doesn't matter how you write it as long as you can come up with it. Okay? Before we do this problem out, I want to go to the next part in your notes quickly and discuss rate of change. Rate of change. In pre-calculus and in calculus, we actually do this in calculus. It's f of b minus f of a all over b minus a, excuse me. However, we better know it as what? When it's the rate of change, what is that? Y, yeah, that's exactly what it is. y2 minus y1 over x2 minus x1. That's really the slope. That is your slope. The rate of change is your slope. Okay, which is your f value in your equation, your linear function, right? So, let's think about it this way. If I had an x value which equals b, we'll call that x2. How do I find y2? Don't I take my x value and I literally plug it in the function and solve for it? Yeah. That's what this is telling you right here. If x is b, well, plug your x in here, and that gives you your y2. If you have an x value that's, we'll call it a, well, you plug that in your function, and that gives you your y value. So that really is y2 minus y1 over x2 minus x2. Oh, nice. So now let's go back and figure out that equation of a line. Example 5. Write the equation of a linear function f such that f of -1 is 2 and f of 3 is -2. All right. Well, we are going to use this right here. We're going to use this right here. All right. Does anyone know what this is called? What type, what form that is? It's linear, but what is this and what is that? What's the m and what's the b? Slope and what? Y-intercept. This is your slope, which is right here, and this is your y-intercept. So this is called what? Slope-intercept form. This is called slope-intercept form. Okay? I'm going to show you another form that we do in calculus that might come in handy sometimes. We use it a lot in calculus. And it states, it's still equation of a line, y minus y1 equals m times x minus x1. All right? And you still have your slope, but you don't need an intercept like you do here. What you need is a coordinate. You actually need a point. You need an x value and a y value, and you plug that in. So this is actually called point slope form. Point slope form. That comes in real handy. You don't have to use it. I'll show you how you can use it to make life a little easier. All right. Let's come up with the equation of this line right here. And let's use y equals mx plus b. Well, I know my equation will always have a y and an x in it, so I need to find m and b. What's the first thing you think I'm going to do? I've got those two things right there. What's that? You can, but you don't have to. You don't have to. What do we just figure out about rate of change? Isn't it f of b minus f of a all over b minus a? Yeah, so if this is b and this is a, well, f of b, which is 2, minus f of a, which is negative 2, all over b, it's negative 1, minus a, which is negative 2. If this is my x value that I'm plugging in, doesn't it give me my y value? Right? Yes, right here, this coordinate is at negative 1, 2. What's the coordinate here for the second one? Yeah, this is my x value, that's my y value. So it's 3, negative 2. Now I have my y2 minus y1 over x2 minus x1. And you can put your slope in there and find your intercept, absolutely. Well, you guys got to realize that when they give you something like this, when they give you these numbers right here, this is your x and y for a coordinate. That's your x and your y for a coordinate. All right, so how do we set up b? How am I going to set up my fraction? Yeah, 2 minus negative 2. Negative 1 minus 3. So this will be our x2 and y2. And this is our x1 and y1. Right. So that is 4 over negative 4, which is negative 1. That's our slope. We now have our slope. So now I need to find y-intercept. How do I do that? You guys should remember. All right. I have my slope, which is negative 1. Okay? I need to figure out my intercept, which is b. Don't I need to plug in an x and a y so that I can solve for b? Yes. I can pick any coordinate. Either one I pick will give me the same answer. Which one do you guys want to pick? 3 and negative 2. So my x value is 3, and my y value is negative 2. That's it, right? That's y equals m times x plus b. Right? Uh-huh. So what do? I've got negative 2 equals negative 3 plus b. How do I solve for b? Add 3 to both sides. And
you get positive 1.
I get 1 equals b. So now I have my b value. I have my m value. I just plug them in and that's my equation. So if y equals mx plus b, I say y equals, my m is negative 1 times x plus b, which is 1. There you go. There you go. That is integrated algebra stuff. But what about this point slope right here? Wait, I'm just going to show you this quickly. Well, do you want to write it down or not? I mean, you can do this and you'll be fine. Yeah, our slope is negative 1, right? So I've got y minus something, y1, equals my negative 1 times x minus x1. Do I need to find an intercept here?
No.
What do I need?
Coordinate.
I just need a coordinate. Pick either coordinate.
Negative 1, 2.
Okay, we're going to use negative 1, 2 as our coordinate. So, y, x. So it's y minus whatever my y coordinate is, 2, equals negative 1 times x minus whatever my x coordinate is, negative 1. So y equals, y minus 2 equals -1 times x plus 1, right? What happens when I distribute that -1?
All you get is negative x.
Negative x, so atoms, multiplying.
All you get is
Then what do I do to get y alone?
x. 2 on both sides.
And what do you think I'm going to end up with when I add 2 to both sides? Y equals -x plus 1, which is the same thing. Don't have to use it. You just never have to figure out an intercept again. You can use either one.
Just talk about this.
Camelot Apartments bought a $50,000 building, and for tax purposes are depreciating it $2,000 per year over a 25-year period, using straight line depreciation. Depreciation means what?
You lose value.
Yeah, you're losing value of something, so it goes down, okay? That's good. So we're going to write an equation for the value, v of t, of the building as a linear function of time. Linear function means y equals mx plus b, all right? But here we go. They want it for value of time using t for time. Now, before we do anything, you know how y sometimes we say it's f of x? Well, they want us to use v of t, value, equals m times t instead of x, because we're using t, plus b. We just got to figure out what's our m and what's our b. What do we think? Well, do you think you know what the slope is? Any guesses on what the slope might be?
225?
It's 2,000, because wasn't slope a rate of change? And how's the building changing? Yeah, it is depreciating. It is going down 2,000 per year. So this is my rate of change, isn't it?
And we also have our C value, right?
So hold on. Which means it's is it 2,000? Thank you. It is negative 2,000 because it is depreciating. Negative. It is going down. So negative 2,000. That is basically your slope. Okay. So I'm going to rewrite our equation here. V of t equals negative 2,000. That's my slope times t plus. What's the y-intercept going to be? Where do you think we're going to start? But if the y represents value, right? If the y represents value, what's our starting value of the building?
50,000.
50,000. So that's what we bought it for. This is our starting value, which means that is our y-intercept, which is our b, plus 50,000. That is the equation that represents the building bought $50,000 that's depreciating at $2,000 a year using straight line depreciation. So our equation was v, and I'm just going to rewrite it so we have it in front of us here. Negative 2,000 t plus 50,000. Okay? So they want us to find v of 0 and v of t. V of 0 and v, of 16. Well, the 0 in for t and the 16 in for t. So what are we going to do? Any guesses?
Don't you just substitute for t?
Yes, you do. What do you put in for t?
0.
This goes in for t, which is right here. Plus 50,000. And the second one is negative 2,000 times 16, because this is now going in for t, plus 50,000. So, what's v of 0 going to equal? What's v of 0 going to equal?
50,000.
Right, so this will become 0, because anything times 0 is 0. Plus 50,000. And what does that mean in terms of time and money? V of 0. What's that equation basically telling me? Yes, you guys are right. Both of you are right. You just bought it, which means if 0 years go by, and you paid 50 grand for it, no time goes by, it's still going to be worth 50 grand. Absolutely. So before you even figure out what V of 16 is, what's that equation going to tell you? Yeah, you bought the building, you had it for 16 years. What's it worth now if it goes down $2,000 a year?
$18,000.
$18,000, absolutely. $18,000. Okay? Now, the last one we're going to do here, before I show you something cool on the calculator, the last one we're going to do here is we don't need to solve for value anymore. Like these first ones here, well, what's the value after 0 years? What's the value after 16 years? This one, they want to know the years it's going to take before the value becomes 39,000. So now, maybe, if V of t is negative 2,000, this doesn't change, times t, plus 50,000. Well, that is going to equal 39,000, won't it? So, what year? One decimal place now. Give me what year, how many years after buying the building will it be worth 39,000? All right. What was the first step in solving this problem?
Subtract 50,000.
You need to subtract your 50 grand here. Absolutely. So I've got negative 2,000 t equals, that's negative 11,000. And then what do I do?
You divide by negative 2,000.
Divide by negative 2,000. So these go away. I've got t equals. Divide this by negative 2,000. And what do I get?
5.5 years.
Thank you. It's 5.5 years. What if I ask for that in years and months?
So it's 5 years, 6 months.
Right. That is not 5 years and 5 months. That is 0.5. That is 1/2 of the next year. So that would be 5 years and 6 months. What if I ask that in just months? Thank you. Yes, and thank you. There are 12 months in a year. So 5 years would be 60 months. Plus it, that would be 66 months. Good. Now, for those of you with calculators, if you don't grab one, turn our calculator on. Hopefully the last class, at least there, it might have. Let's do this. If they left it in there, do me a favor, hit second, the plus sign, and 7, 1, 2. Just to clear everything. Okay? When you do that, let's go to y equals, and we'll put in our v of t equation. It's negative 2,000 x plus 50,000. Now, if I want to see this graph, what do you think I should change the window? I'm not going to make it 10 by 10, but it's 50,000. So if I go to my window, let's talk about the x, which is my time. We should start it at 0. How far out do you think we should go?
12, 20,
A little bit more, I go a little bit further.
30?
I'd say either 25 or 30. Why would you say 25?
That's like 20 years.
Yeah, it's how many years he has it. It goes out 2,000 a year for 25 years. It's worth 0, right? 50,000 right there. So let's go to 30, because it's just 5 years past. And I don't want to see this x scale means how often you want to see a tick mark. I don't want 1, because I want to see 30 tick marks. Maybe 5, maybe 35. Now, the y min. Yeah, it's 0 when it's worth $0. Where do you think I should start? 50 or 55, it'll go a little bit above, but 50 will be fine, or 55. I'll use 55. Well, you could definitely use 50. That's fine. In fact, if you want to use 50, the graph should look almost the same. And what do you think of this? I don't want to see 55,000 tick marks. I do every 5,000, maybe 10,000. So you only see like 5 tick marks, so it doesn't become overbearing. Now, if I graph this, that is a straight line depreciation. As I move to the right, that's as the years go by. And as the graph lowers, that's the value. The value lowers as I go to the right. But here's the cool part. Let's look at the table. What did we say v of 0 was when we did the work? 50,000, because when you first bought it, Look at that. So when my x, that represents my time, and my y is my value. So at 0 years, that's 50,000. And what was b of 16? So guess what? After 16 years, 18,000. Look at that. Perfect. And we said it was going to be $39,000 in what? Around what time? Yeah. So now I'm not looking at my x anymore. I'm looking at my value, which is y. I want to figure out the next 39,000, right? It's between 5 and 6 because, yeah, we don't have decimals for our x, so we can't find. But right between 5 and 6, right here, 39,000 is right here between these two, which is right between those two. And we came up with 5.5. Question. Let's say someone gave you this building, and you really get sick and tired of owning it because there's, you don't know plumbing, electric, it's a lot, you don't know landlord, and you want to buy a car for 10 grand. What year do you have to sell this for? What year should you sell this so that it's still worth 10 grand so you can buy your car?
So if you get,
Look at it. Look at where tell me the year.
It's at 10 grand.
So if I scroll down here to see what my y value becomes $10,000,
who wants the money in the pocket?
that would be the smart thing to do. But when is the very last year you can have it? It's selling to still make it. Because after 20 years, there's your 10 grand for your
And it's
car.
not like,
Okay.
pocket for 40,000.